Hello, this is Paul from Foresight Tech. In this lecture, we are going to learn limit laws. That's the basic limit law. We will use the law to calculate the limit. Here is the summary. So the first we call the sum law. Okay? The law of sum, or you can say the property, okay, of the limit. So can we see the limit of a sum equals the sum of the limit. I cannot give you exact proof in this lecture, but I will give you intuitive proof here. We will get the idea why the limit of the sum equals the sum of the limit. The next lecture we will going to learn epsilon delta language. Okay, use that language we can prove some of these properties. So can we look at it? Why the sum of the limit of the sum equals the sum of the limit. So let me draw a graph for you here. Okay. So for example, if we have a function, here's a function. That's y, that's x. If we have one function, so like this. If this is f, if we have another function like this, this is g. So add the two functions together, or the sum of the function is this, right? Much higher. Okay, probably like this. So these we call the f plus g. Okay. And then we look at one point. Okay, if this x coordinate is a. Okay, so look at how high is this point, or you can say how high is this. This is fa, right? How high is this? From this point to the bottom is g at a. So how high is this? Okay, so if I simply say it is high, okay, so this total height should be the sum. That's the definition. So this is f at a plus g at a. So now we look at the limit of this function, the sum of the function at this point x equals a. Can you see what is the limit? Okay. The last time we define what the limit. When x approach a, no matter from the left or x at here, approach a from the right. Okay, so we can see the height of the function f plus g is always gets higher, or always approach to fa plus ga. That's exactly the results. What does it mean? Can we see? So the limit equals what? Equals fa plus ga. Fa plus ga is just the limit of f and plus g. Okay, so this is just a basic idea. It's not a proof. Okay, exact proof we need to learn epsilon delta language later. So that's the first. So how about the second? The second is similar, right? So this is the difference of two functions. The limit of the difference equals the difference of the limit. You can imagine, okay, it's the same. If f(x) approaches to a number, g(x) approaches to a number, the difference, of course, is approaches to the difference of the two numbers. One more, we call the constant multiplier law. So can you see? If c is a number like a 2, double f, okay, so the function will get double. Of course, the limit also gets double, right? Okay, if c is triple, is 3, so the limit should be triple of the value of the function, definitely. Okay, all this is basic. So if we put these three together, we can say it's a linear property. If we merge these 1, 2, 3 together, we call the linear property. Can you see what is a linear property? We call the linear property. It's just this. The limit of a linear combination of two functions gx, this linear combination should be equals the linear combination of the two limits, which means f(x), you can put a here, right? And then the limit x put a gx, put a b here. Can you see this? The linear combination, the limit of the linear combination is the linear combination of the two limits. Okay, so the limits can go here and go there. Later we're going to use this linear property. It's just a summation. Okay, just a summary of these three laws. We'll look at another law. So we have a few more. And this is the product law. The product law. So which means the limit of the product equal the product of the limit. Okay, so you can imagine. Okay, it's easy to think about this result. The same we have a quotient law. This is the quotient. The limit of the quotient equal the quotient of the limit. And the power law. What is power law? Can you see this? If we have a power of a function, the limit of a power function equals what? Equals the power of the limit. Okay, which means what? The limits can go inside the base. Okay. We'll show you a little more. You see. So we look at the power law. If I give you a simple example, if the function is x raised to the fifth power, okay, can you see this function? We take x approach a. I still use a. So this time we can use the power law, right? So which means that the limit can go x. Can you see the power law tells us, okay, x and put a parenthesis and raise it to a power, which means the limits can go to the base. Do you know what is the limit of x when x approach a? Of course, the x approach a is a, right? Definitely. So this is what? This is a raised to the fifth power. Okay, if I change 5 to 10, of course this is a raised to the 10th power. Means what? We directly substitute. Okay, so the x substituted into a. This we call it the power law. We have one more law we call the root law. It's just the opposite procedure. It's similar as the power law. Can you see? That's the nth radical. This nth root. That's a radical, right? Radical is a kind of power, just the power of 1 out of n. Okay, what is the limit of the root? The limit of the root is the root of the limit, which means the limit can goes in. The limit can goes in here. Okay, it's similar with this. All these properties we only can look at it, the intuitive definition of the limit. So next time I will give you exact proofs using Epsilon data language for some of the laws, not all of the law. So we have the last direct substitute property. Okay, direct substitute. What does it mean? If a function is a polynomial or rational function is the quotient of polynomial, right? It's their kind of polynomial. If we have a polynomial, okay, so the limit of the polynomial equals what? Equals the value of the function at a. Okay, directly substitute x by a. I have to give an example. Can you look at this example? Okay. So we already have, you can see, we take an example. Yes, so get it here. I take an example. So f is this. We pick f. Can you see? We pick f is a small polynomial, a raised to the second power. Okay, x to the second plus a1, x plus a0. I give you the smallest polynomial. It's very small. Okay, it's only the degree of 2. What is the limit? Can we see? Going to see the limit x approach. I use a. Okay, it's a constant number, and the fx. So equals what is the limit x approach a. Okay, all this, right? So there's a 2x squared plus a1x plus a0. Okay, can we see what kind of law we can use to find the limit? And I'll show you this step. And this is what? This is a linear combination, right? Do you remember we have a linear property? So linear property, the linear combination of the function equals the linear combination of the limit. Okay, the limit of the linear combination is the linear combination of the limits, which means what? The linear property. So the limit can go to, if I write down, is a2, the limit x approach a x squared. Okay, and this is a constant number, so a1, the limit x approach a x. Okay, so this function, the limit of a0, of course, the constant number, the limits are always equal to itself. Okay, is a0. Can you see this, the linear property we just say, right? Okay, what is this? This is the power. The power rule we can use. Okay, directly we have a2. The power rule is the limit goes to x, which means a put here. So v times a square. So here is a1, is there a1, and the x put a. So this is a, right? And then plus a0. What do we get? So you can see. So you finally get what? We finally get this is just the f at a, is f at a. Oh, wait a little so you can see. Okay, so the function of f is a polynomial. Our result finally is the value of the function, the polynomial at x equals a, which means what? If we from the beginning, the limit of the function equals the value of the function at x equals a, which means f a. Directly substitute. In the future, you don't need to do the middle. You don't need to do the middle. Directly substitute. So that's an important property. Okay, so we can see we already have. That's all the basic properties we learned. And then I give you one example. We have a different laws, right? A linear property, sum or difference or constant multiply, or product or quotient law, or power law, or root law. Okay, if we deal with the polynomial, is directly substituted, or if we deal with the rational, is the same. One example. So can you see these questions? If we know the limit of f as x approach 2 is 4, this limit is negative 2, this limit is 0. All we deal with as x approach 2, right? Okay, and the question says if the limit, this means does not exist. Okay, can we see one by one? The first, what is? That's a linear combination, right? Okay, this coefficient is 1, and which means we combine f and g together. Which law we're going to use? We use the linear property, or you can say is use the sum law and then the scalar, the constant multiply law, constant multiply. We put them together. See, we're going to write. What do we get? We should get directly put here. So the linear property, or we say we use the linear property. If somehow you don't like this name, it's just what? It's just a sum, right? It's just a sum, sum law, or and constant multiply law. So constant multiple law. Okay, so put these two law together, we can solve this. So what the results we can get? We can see this. Okay, so this is the limit one by one. The limit as x approach 2 at f plus 5 times the limit as x approach 2. Okay, can you see the linear combination of two functions? The limit of two linear combination is the linear combination of two limits, and then all we need to do is what? So find out what the limit of f is 4, or the limit of g is negative 2. Therefore, what do we get? We get this. This is 4 plus 5 times, this is negative 2, so negative 2 for here. And then do calculation. This is 4 minus 10 is negative 6. Okay, this is the first question. I'll look at the second part. The second. Okay, so which law to use now? You can imagine which law to use. This is what? This is exactly a power, right? We have a power law to use. Okay, so if I put here, which one to use? Is power law we can use. Okay, power law tell us, okay, and the limits can go to the base or the function gx. So what do we get? And we definitely get this, that the limit x approaches 2 gx, that the base, and then we put this big bracket raised to the power of 3, right? So this is what this is the power law. Okay, now what do we need to do? What the limit of g is -2, we plug -2 here, and we will get -2 raised to the third power. Of course, to calculation we get a -8. This is the second, the bit a little bit more, and we see all we need is the property, right? Okay, so look at this. If they are the same, okay, and we're going to see which law to use now. Is the root law, right? Because this is a root of a function, the root function. So which law to use? We know is the root law. Okay, how do you say is this? Okay, we're going to root, which means the limit can go inside the under the square root. Okay, under the square root, and we directly put it here is go inside. So we have a square is the out. Okay, the inside this x approach 2. Okay, so we have a fx, right? Fx, okay, which means what? The limit go inside the square root. We call the root law. And then all we need to do is plug. F is 4, so is a square root of 4, and is 2, right? Okay, so that's easy to get. So one more. Can we look at this? Which law to use? So first is the quotient, right? So we use the quotient law first. You can say we're going to use a quotient, right? Other than quotient, and then 3 times f is a constant multiplier, or you can say another is constant multiplier, and then is a constant multiple loss. We merge these two together. Can you see what do we will get? We will get this. That's the the fraction, the quotient. The limit goes to here. I guess approach 2. Of course, the 3 is a constant multiplier. We put out, so up 3 put there. And see, this is fx. Okay, the bottom is the limit. I guess approach 2 at gx. Okay, good. Now all we need to do is just plug. All we need to do is plug. What is the limit of f at 2? Is 4, right? So we have a 3 times 4. The bottom is -2, so we put the -2 here. To calculation, we get a -6. Okay, this is the answer for this part. One more part. All this is the rule, right? So the last, can you see? And this is the quotient. You can say the quotient, right? Definitely. Good. So we still use the quotient. So we say use the quotient law. Good. We use the quotient law. However, we will get something different. Can you see this? Okay, if I put the quotient law. The quotient law means the limit of the quotient is the quotient of the limit. The limit goes to top, the limit goes to bottom. Okay, x approach 2 gx. The bottom is the limit of h as x approach 2, and then you know what do we get? And the numerator g is -2. Good. The denominator is what? Can you see this is strange? What do you get? It is 0. Do you think we can put a 0 to the denominator? No, we cannot, right? So we cannot do this. Oh, simply say we cannot do this also. If you do that, you will get it 0 goes to the bottom. So what do you say? We say this is does not exist. Okay, so we finally say this is does not exist. If it exists, so if we use the quotient law, we get 0 goes to the denominator. Okay, so this is the last one. We say does not exist. That's all. Thank you.